we're excited to be here for our second Access event, the first one in EU, Amsterdam. It's a lovely city, my first time. So we hope to make this a regular thing and make it a tourist destination for the conferences. We can call it the Green Light District instead. Yeah. So we're going to go, and I'm going to talk about some new things here that are situational around risk for all of the types of activities that we're doing as institutions building DLT. And I know Rob, at the beginning of the day, we read the same things, I think, because we have the same quote there. So I won't do it again. But this is becoming a real topic. And every day we see more and more around Larry Fink from BlackRock, next generation for markets, and next generation for securities, tokenization. And DLT is growing from Goldman Sachs to all of the institutions that are represented here and have come to join us to learn about risk. So that's why we're here. We want to know about it. And there's a lot of infrastructure, a lot of solutions that exist. And it can be overwhelming to know what are the best, what do we do? And this is just an example of DLT, when we talk about distributed ledger technology, it could be blockchain, it could be a hash graph, it could be a hollow chain, it could be a tempo of radix. And I'm not going to go into explaining what all of these are, but they're different forms of delivering similar technology for the same solutions and benefits that we're all looking for. Mostly, we are going to discuss some risk opportunities in the real world on blockchain. That's the one that's really taken off. That's the Blu-ray versus the HD DVD of how this is all coming out for DLT. So what is the purpose? Why do we try to build something new? What's moving from Web 2 to Web 3? There are some core principles, and we're going to reference these as we talk about risk in the coming slides. The primary purposes for why we're investing our time, energy, resources, and our knowledge base into this. So one of the core purposes is to ensure data accuracy and concurrency. This is consensus to make sure that we are using faster settlement here, and we can ensure that accuracy of an immutable system, that the ledger is updated correctly, and get away from this replication that we constantly see sometimes that can cause issues for security, as we'll discuss soon. Also, we want to establish security between participants, this peer-to-peer type of methodology that we hear so much about, and that could be through cryptographic algorithms. It actually is through cryptographic algorithms or asymmetric keys. Another way is to increase speed. So this peer-to-peer connectivity that we have is creating layer 2s, scaling systems, is doing Merkle tree validations, faster transactions. That's one of the core purposes we're looking for all this fast settlement. Information distribution. We are in the age now where we want everything instant. And as our generation is growing, the millennials and the Gen Zs, and we see them, they want things faster. The banks and institutions, they have to keep up with that demand too. They're going to be upset if they have to wire transfer something and they have to wait till Monday in order to get their dog token, the next week. So also to increase transparency, and it's a verifiable ledger that we can go and look at the records of the transactions. They're often bridged together through this monolithic system. App chains exist also, and there's multiple ones that interact and connect together so that we can get transparency and traceability. And then finally, probably the most important thing is to reduce costs. So I'm not here to talk about the uses for it. I think we get enough of that. We're a cybersecurity advisory and testing firm. We're not here to build it. We're here to break it for you and talk about risk and what you should think about as you go into this. And I'm going to go and illustrate 3 different types of use cases in 3 different sectors, and then talk about some specific risks that we may not often think about as we're building this. And hopefully you can leave with a couple questions and consider these topics when you go back to your day-to-days and work with your teams. So the first one is financial sector, the second one government, and third consumer and retail. I'm going to spend some more time on the financial market sector. And I'm going to use an example of the use case here that is discussed today a few times, and we're going to talk about it some more later today in other panels. But bond issuance and tokenizing bonds and other financial assets. this can be secondary market or primary markets, but when the primary markets are concerned, they're the ones that create bonds or tokenized bonds, and they give them directly to investors. And bond issuance is usually for creating new debt for the market to raise capital. This can be government bonds or other ones as well. So let's look at how it's done today in the TradFi world. There's these parties involved. I have two separate areas that some of you may be familiar with. But you have one side of it that's providing oversight, issuance, record keeping. And these are things like the registrar, issuer, paying agent, common safekeeper. They're here to make sure that they're recording who owns the bonds, how much principal do they have, keep track of the name of the owners, what the bonds are. There's the payer agents are the ones that make sure that the issuers get it to the bondholders and the people buying it. And when the bond matures, the record keeper has to keep track. There's a lot of processes that are done, Web 2 systems or manual record keeping. And then you have a clearing system on the other side. The clearing systems are doing a lot of the plumbing. You have confirmation. You have the settlement, to making sure that the actual the issuer is receiving that into the buyer's accounts. And you have the payment systems. The Fedwire system is one. The SWIFT system. These are ones that we're trying to replace or improve and make better with all of this. And the infrastructure behind that is really some of those core purposes that we see for DLT and everything that we're here today to talk about. And it can get kind of complicated. And complexity is the enemy of security, we always say. It's the enemy of many things, actually, but it's the enemy of cost as well. If you have overly complicated systems, they can make things much slower and much more expensive. And you have this interconnectivity of registrars that need to be updated from everything. I mean, it works somehow. It's very spaghetti. DLT is as well. But let's see how are we doing that, and how do we see it done on a system that is using blockchain or a DLT, and some of those benefits and purposes that we'll talk about here, and then moving into the risks as we do that. So you have a digital ledger. It's a immutable record keeper to keep track of that bond life cycle, and you have a tokenized bond that the token is usually a smart contract, and that smart contract is it's Turing complete. It has functions in there and applications that can update things. It could say how much yield does it deliver, when is it going to expire, when is the bond up, there's lots of information within it. It's a program that keeps track of a token. You have a digital ledger itself now can act as a intermediary. That's really that communication using the cryptography, being able to track that and encrypt it and secure that transaction. You don't have to have a database somewhere else or a record holder, because you can see that you trust the ledger for that. That's the ledger technology. And bondholders, they on-ramp, off-ramp cash. Over here, you can see that you have these USDC circle represented here today, and other ones that turning dollars into a dollar token or a bond, and back and forth. It's the on-ramp and off-ramp. That's the adoption part that we're all trying to make a lot easier too. And some benefits now is you can have this settlement instantaneously between the bondholder and the wallet, as long as all the rules are in place and the contracts work appropriately. And if you want to do all of the oversight, you can have some third party without manual intervention, having E&Y or somebody come in and say, give me all your paperwork and let me go through it all. They could, maybe look on the digital ledger, when they need to, because that's the transparency behind it. So that's bonds is one example, but we also can do the same thing with, securities. And this is, exchanges of brokers, secondary market transactions, the securities holders. You can have the order book on here, and you can have a CTA be a contract in order to help collateralize, match the bids, the ask, and show all the spreads. It's all there, and it happens a lot fast. This is some of the things that we see being built right now by a lot of the markets and exchanges. So one more stat, and we'll talk about some risks here. Multiple days to under 15 minutes in some examples for ones that are being implemented right now. That is a huge update to what we're used to with the traditional systems. And the cost, 50 to 70% in reconciliation auditing time. All those interconnected webs of third party people auditing things, having the record keeper update their records, making sure that the bondholders are updated there. I mean, this is why the system is kind of slow. So it sounds all great, but what could go wrong with this, right? Sounds beautiful, but there are risks that we consider. And I updated this, actually updated this deck for something that happened 4 days ago. And I couldn't resist it because it's something that I talk about and then it happened in real life. I want to use it as an example. Does anybody know about 4 days ago when New York Stock Exchange had that issue where market opened up and the Berkshire Hathaway, yeah, I see some heads nodding. It was for sale for $185 instead of $627,000. Yeah. And so I saw that on Zero. Anybody read Zero Hedge here? Yeah, I love that. Yeah? Okay, more nodding heads, great. White people. So on Monday, earlier this week, they opened it up, and the price of the shares, not just Berkshire, that's a big one, but there's other ones here, were wrongly reporting the cost at the opening of the market. And it allowed a lot of those trades to settle for 99.9997% discount. And how did that happen? It happened because there was a software update that was done on the SIP, or the Securities Information Processor. That was just a software upgrade in the back end caused an issue at the opening for several equities, and they had to halt it, say, whoa, 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 nobody's allowed to have that much of a discount on this share. That's not reported right. So they halted it, and then they reverted back all those, with the 2 minutes that it was open, they reverted the trades. They said that, oh, those trades don't count. Reset them. You guys didn't get that cheap. It's the right thing to do. Nothing wrong with that. It was an error. But what would happen if this was an immutable DLT and you had tokenized securities and you're on-ramping this to Ethereum, and all of a sudden, those Berkshire, A securities tokens went into a user's wallet, from, their Robinhood app, and they say, oh yes, whoa, YOLO, super cheap. What are you gonna do? Like, it's immutable. You can't revert that. You can't just reset it. So it's a risk, and how do we solve for that right now? And because we have this discussion on, all right, what do we have to do to prevent this type of incident from happening? It's obviously should not happen. It can't happen, but it's one of the quirks of DLT. So imagine if you wake up and the headline said, any settled trades that occurred on Berk below that were unable to be recovered due to the mutability of DLT, instead of what it was. During the window, we reverted and canceled. What do we do for that risk? So one thing that we'll often hear is, okay, we need to make sure that we add some approval and oversight before any of those settlements happen. We need an upper limit and a lower limit to have an approval. Like, hey, if this is something that's like 99.99% off, even if like 5% off what we expect from like a bid or ask or a bond cost, we need to route it and say, hey, why is this happening, and have an approval. All right, so we're going to have oversight. We're going to stop the transaction, have like a middle man to review it and audit, make sure like this one passes our compliance or our risk tolerance. Well, there goes some of the primary purposes that we discussed in the beginning. Now we are adding in, data concurrency, so where the increased speed's gone out the window because now we have to stop it and review it. You don't get that instant settlement anymore. And now we need people, cost, labor, teams, infrastructure added, in order to add there. So, all right, how about we add a burn and a mint and a retrieve function, perhaps. You can call it whatever you want, but essentially it's a function in the smart contract to say, we want to do what TradFi does and cancel that transaction. So some things you can do. This is this isn't the Berk securities token contract because that doesn't exist yet. This is an example of some typical ERC20 tokens that we see here. You'll have approve, you'll have burn, you'll have all these other functions on here. For example, one of them is burn mint. Let's just zap those tokens and they never exist in that wallet anymore. Or let's make mint some more and then remake and reissue it. Or retrieve it. Let's just withdraw that out and bring it back here because that wasn't supposed to happen. Okay, that's is a solution, and that it's a solution that is used today for things. But here, what about the risk in that now? We're opening up a risk. So instead of this smart contract function allows issuer to delete token security if they have the private key, the risk is, well, now what happens if this smart contract function allows the hacker to delete all tokenized securities if they steal that key? Because that function is signed with a key in a transaction, and if it gets in the hands of the wrong person, that's devastating. We have an even bigger custody risk now. It's like, holy crap, every time we have a solution, it's creating another risk. So, all right, that's another thing we could do to prevent it here, but we also there goes all of our purposes now, because that just, all the whole increased transparency, that's not very transparent if you can say, hey, well, you thought you were distributed, but you're not. You're actually, we can mint and burn it and retrieve it whenever we want. It's like, put my money back in my Wells Fargo account, please. And also, like our security between participants. It's not very secure now if there's a key available that could possibly be stolen or used fraudulently to leverage these functions the same way. And there's a solution for that, and then that creates another risk and a solution for that. But really what is happening is we're creating what I'm calling it a risk cascade, where this scenario I just went through that's related to what we just saw earlier this week, you have a DLT implementation for security. All right, that's going to increase the risk of that irreversible settlement. It's like, oh man, okay, so what do we mitigate there? Approval steps. That's going to increase the risk and have a reduction in speed and transparency. All right, that solves one, but now that game of whack-a-mole, and then you mitigate that, the burn retrieve, now you have the increased risk of security, increased costs, and so on and so on. So it's all about risk mitigation and where your appetite is and understanding like what can happen. It's like threat modeling in the security world, they call it. So I'll move into another use case from the financial market. So government. In the US, the elections are coming up later this year, and last year was during COVID time, and we had this great mail-in voting system that was being used. So really, there's two ways in order to put in a vote for an election or whatever it was that you were voting on for the government: ballot box or mail-in vote. So you have local citizens at each state. They go in and they report the results of that. They put in you go physically to the office if you're doing the ballot box and put your vote into the, for when I did it, put it in the computer and then prints out something and then you give it to some person sitting at the table. And it's done for each precinct, and then that's sent over into the precinct. They vote for electorates, so your delegated voting process from the popular vote. And then they count those up and then they tally the results. Meanwhile, we're all thinking here like, well, I hope they counted mine right. I don't know. I just gave it I put it on the table, so hopefully it got counted. It's supposed to. That's like the democratic way. But there's who knows? We don't know. That the transparency there. So there is a patent out there right now. This is I have the link on here. You can go look at it yourself here. It's for the U.S. Post Office has a patent for a secured voting system on chain on DLT. So it's out there. It's actually quite elegant. I think it's an excellent solution. Basically, what would happen for this is you would have a user register their ID. Can be KYC, make sure they're in the database. Check it against the normal you're a citizen of the United States or whatever country you're in. They would generate the key, tie that to their identity, and then they could vote on a blockchain with their key. There could be metadata attached to which precinct they're from. It'll be written on chain through zero knowledge, so it's not going to be kind of privacy hindering. It could be a zero knowledge as well. And it goes on chain here, and you can even go back and check it yourself if you want. Make sure that it's registered there because you have your key and you can your public key. And if you want, you could even write a script and tally up all the votes yourself and know it was counted correctly for everybody. And anybody can count it. Anybody can see precinct notice. So this is a great solution for DLT. So what are risks with that we have to think about? And these are, they're not a stretch, and they're actually quite predictable for what we see in any technology system. But you can have fraudulent key generation. Somebody fake ID, they're making a key on behalf of somebody else, and now they're voting for that. That's really not unique to DLT, but it's something to think about because the process changes. You have a key now that is signing votes, and you can't really call the help desk to say, regenerate my key or my zero knowledge proof for that. The Merkle tree, I'm not part of. It's a lot. The script for the help desk has to change. And there is also a PII data breach on chain. We at Halborn, I mean, standing right in front of me, him and many others have found errors in cryptographic protocols where we think it's doing cryptography, but you can generate the IV and start using some initialization vectors to decrypt it, and it's really not encrypting anything anymore, and you just reconstructed the private key. So there's a lot of issues, deep technical ones that may cause issues with the privacy. And if you could do that, then you have a skeleton key, essentially. Maybe you can see all that. It's just like getting admin in a database and dumping it, and now you can see all of the credit card numbers. So it's the blockchain version of that. All right, so let's move on to a third and final one, consumer retail. I like this one. This one's a little bit happier, and this is actually something that Louis Vuitton's a huge European company. I think one of the biggest. I like Louis Vuitton, and this is they have a blockchain rewards membership authenticity. This is functional right now. This is actually my portal. You log in, and you can see it's in a My Via portal, and you put in your Ethereum wallet, and when you have it in there, you end up getting different things. You could register your items with that key that you purchase, and you could retrieve airdrops from them. Like this is a treasure trunk, and if you have a treasure trunk, it's like a kind of like Louis Vuitton's version of a Bored Ape, where you get the airdrops coming in for that. If you visit stores somewhere else, you get a passport for that, and now you're earning rewards, showing you're more loyal for it. It's super cool. Obviously, I travel a lot, so I think the Amsterdam one actually. I'll do that before I leave. So you have that. The tokens are issued for the locations you go, and then register those. It's a pretty neat system, and you do get like physical redemptions for that stuff too. It's quite valuable. They're doing this as well as authenticity. So they have official smart contracts that are deployed on chain, and those smart contracts, they're check marks, so it's them from OpenSealWeb. They allow provenance. You can see who owned it. Let's say it's a big problem of buying knockoffs that look really good. And right now, what do we have to secure? Like the serial number, you just copy the serial number on another one that looks good, and it's like it looks like a replica. But you can't really copy a private key that works against their smart contract. That's the asymmetric key. So they're tokenizing merchandise with that private key, so you can verify authenticity. If you want to sell it on secondary market and on eBay or something, you could give them the key with it and say, here, this shows it's authentic for that. So it's it's using decentralized for authenticity. And of course, got to talk about some risks there. So one is just like user knowledge. Adoption and understanding how all this works. I mean, we're a smart group here, so it makes a lot of sense to us. But go to some Instagram influencer that likes to buy Louis Vuitton purses and be like, do you have your private key registered for your purse there? It's like, I don't know. But that can happen. Logic and code flaws can lead to risks, like everything else has a smart contract. There's flaws in there. What happens if I figure out how to hack the system a bit on that contract, and I start making my knockoff purses that look really good, and I start using the key to authenticate these knockoffs. Now we think there's a real one with provenance on there, even worse. You can lose the keys as well, and you can have issues with like the memberships and the access for that. So here's like a real world use case that happened a couple of years ago with Adidas. Adidas, credit to them, they were one of the very first large companies in the consumer retail space that were opening up the doors for this. You have Adidas Originals. I don't know if any of you guys did this or not, or if you degen as good as I do, but they had the track suits that you could get with that. And everybody is so hyped about it, and it came out. And right when it came out, they were gone. And one smart threat actor, I guess you could say. I don't even know if he's a threat actor. He just figured out how to buy all of them. It costs a lot of gas. This is the way he did it. Kind of at high level is he created his own smart contract that would create mini smart contracts because there was a limit how much you could buy. Only two NFT tracksuits from Adidas per wallet. So he was like, well, if I can have a contract that can make other contracts that can make each one of them get two, I can buy all of them. Now, it's a lot of gas to pay it, and he paid $252,000 in just gas fees to run that transaction when it came out. But he also owned all of it, and then he ended up selling them at a profit and made $600K. And I think he kept a couple tracksuits too. You can see all the transactions here from the Etherscan of this all happened in atomic transaction of 2, 2, 2, 2, 2. So, and Adidas was like, what the F just happened? This blockchain stuff sucks. No, it was actually a use case to show awareness. Now, they're early with it. There's these risks like this that we've never seen before when you adopt the technology. So that's what I really want you guys to take away from this is, as we go off and build all the cool things that we're talking about today, some of the main things to think about is understand, what is the business purpose? What are you doing this for? What are those core purposes for? Are you doing it for, speed, reduction of cost, security? It's impossible to avoid all risk. That's that risk cascade, especially with new technology. There's great risk, great reward as well. Sometimes mitigating one risk will open up another one. You have to understand that there's not, you can't call Halborn or any other security company and be like, all right, they did it once, we're good. No, there's gonna be, it's a continuous thing. There's always gonna be risk. And finally, if I say a word of advice, the best way to do this is, as you build, think about security, do threat modeling, determine what are the acceptable levels of risk that you're allowed and know what they are. Being aware of that is the first step in that. And which ones should be mitigated, which ones should be accepted. Okay, thank you, that's all I wanted to go through. You guys enjoyed it all?